Now let's understand the nitration reaction. So we are going to discuss the preparation of nitroalkane. So the first method of preparation is using nitration, wherein we will be using concentrated HNO3 and H2SO4, because we are going to do the nitration of alkanes which are saturated, so they are normally not reactive. Okay, so now we have two nitration processes. First is called as vapor phase nitration. Now, what exactly is vapor phase? So, vapor phase means this is going to be at a very high temperature. Okay, so you take methane, which I am going to write it as CH3H. Methane is treated with vapors of nitric acid. So, I am going to write HNO3. HNO3 I can write it as HONO2. So, now H and OH goes in the form of water, as a result of which you get CH3 NO2 and H2O. So this is at very high temperature. Many times we would need a catalyst, because otherwise the reaction itself is very slow. Now this was simple alkanes. Now we are going to study what would happen if you have a chain of alkane, chain of carbon atoms. So let's say if you have something like this, CH3, CH2 and CH3. Okay, so now this would undergo nitration. So what exactly happens? So due to high temperature, the bond between carbon and carbon would be cleaved. So NO2 would be coming here and NO2 would be coming here, correct? So this is exactly what happens. So you get a mixture of nitroethane, that is CH3, CH2, NH2, and nitromethane, that is CH3, NO2. You get a mixture of CH3, CH2, NO2 and CH3, NO2. This is nitroethane and this is nitromethane. Now, what other possibility could be there? Okay, you could get something like nitropropane itself. Okay, so you could get something like this, 1 nitropropane. Now you could also get isomeric nitropropane. So it's going to be CH3, then this is connected to CH, and there will be this NO2 and there is a CH3, correct? So at different temperatures you get different products, or many the similar reaction you get lot of products with the lot of byproducts as well. Okay, so in the same reaction we not only get the desired product but also the byproduct. So separation may be a very big problem in these reactions. Now let's move on to the next part, that is next method of preparation. So first was vapor phase nitration, then the next is liquid phase nitration. The drawback of this reaction is it's very slow and it takes hours and hours to complete. Okay, so this is normally not preferred because of its slow reaction nature. Now what exactly happens? So you have CH3, CH3. This is strongly heated in HNO3, that is liquid HNO3. That means you could say something like it's not completely dilute, but it's neither that concentrated nitric acid, wherein you get CH3, CH2, NO2. Okay, so you get nitroalkane, very high temperature. High temperature is needed so that the reaction happens, and the drawback of this reaction is that it is very slow reaction. Okay, so the third method of preparation is basically electrophilic substitution in benzene. So this is going to be the method of preparation of aromatic nitro compound. So we would be getting aromatic nitro compound. Okay, so let's see what exactly would be the reaction conditions. So benzene rings, they undergo nitration, which is again an electrophilic substitution reaction. So we are going to use HNO3. So this is concentrated HNO3 in presence of concentrated H2SO4, which is normally called as a nitrating mixture, correct? So now HNO3 I can write it as HONO2, correct? There is one hydrogen over here, so H and OH goes in the form of water, as a result of which you get nitrobenzene. Okay, you get nitrobenzene plus water. Yes, so this is what you get. So you get nitro, benzene and water. Okay, so this was about the nitration reaction and vapor phase nitration as well as electrophilic substitution to prepare a nitroarene. Now the next method is from alkyl halide. So we are going to study two reactions. First is using silver nitride and the next is using sodium nitride. Now, alkyl halides, preferably alkyl bromide or iodides, undergo reaction with silver nitrite to silver nitrite and not nitrate. Okay, nitrate is NO3. So, what exactly happens is AgBr is released and you get RNO2. So, you get RNO2 plus AgBr. Okay, so you get a nitroalkane. Similarly, you could have treatment with NaNO2, that is sodium nitrite. So Na goes with Br in the form of NaBr and then you would be left with RNO2 plus NaBr. Okay, now in this case alkyl bromides and alkyl iodide give satisfactory yield. So they give satisfactory yield, whereas alkyl chloride the reaction is very slow. Okay, so this was from alkyl halide. Now we can also use KNO2, but we don't get the same product. So I would write from potassium nitrite, it does not form a nitro compound. Okay, so what exactly happens is you get RONO and KBr. Okay, so this was about preparation of nitro compounds, from halides. Now we are going to discuss what would happen if we try to prepare it from amines. So tertiary amines on oxidation give nitro compounds. So I would write R, C, R, R, correct? And this is connected to NH2, right? It's not actually tertiary amine, it is tertiary alkyl amine. Okay, so now this on oxidation, what exactly happens? Oxidation is removal of hydrogen and addition of oxygen, as a result of which you get R, C, R, one more R and NO2. Okay, so you get a nitroalkane in this as well. Now the next method is using alpha halo carboxylic acid salt. Okay, so now we are going to write down Cl. This will be CH2, right? And then you would be having C double bond O, O, N, A, correct? So now this on, so what exactly happens here? So if you could see here, this is carbonyl carbon, so this is alpha carbon. To alpha carbon a halogen is attached, so alpha chloro sodium acetate. Okay, so this on treatment with NaNO2. So what would happen? This Na would go with this Cl, as a result of which what do you get? You get NO2 and this is connected to CH2 and then you have C double bond O, ONA. Now this would undergo soda lime reaction, that is decarboxylation. So this on treatment with sodium hydroxide and calcium oxide, that is quicklime, this entire part would be going with NaO, as a result of which you get NO2CH3, which is nothing but nitromethane. Okay, so this is one of the easiest method of preparation of nitro compound. So this is one of the easiest method of preparation of nitro compound. So first is using AgNO2 and NaNO2, and next is using tertiary alkylamine, and you could use alpha halocarboxylic acid as well to get nitromethane in good yields.